Steam turbine cycle part 3. So in this video, I'm going to explain subtopic number 4, which is the actual Rankine cycle. Actual vapor power cycle. Actual vapor power cycle. So in the actual vapor power cycle, we have irreversibility, which is coming from the fluid friction, and that leads to the pressure drop and also the heat loss to the surrounding. And due to these two factors, the thermal efficiency of the system will be decreased, and in order to cover up, we need to increase the work by the pump and also heat input by the boiler. However, the turbine also will be work by the turbine will be decreased. And this is the TS diagram of the actual and also the ideal cycle of the Rankine. As you can see in the uh, actual cycle, we have irreversibility in the pump, we have also pressure drop in the boiler, and also we have irreversibility in the turbine. And the last one, we have pressure drop in the condenser, and that lead to the shifted of the actual compared to the ideal cycle. And however, in this study, we look into these two process, which is the process of the irreversibility in the pump and also irreversibility in the turbine. And as you can see from this TS diagram, we have one goes into 2S, which is the isentropic process, and one goes into 2A, which is the irreversibility in the pump, and it considered as the actual process. And another one is the 3 to 4S, which is the isentropic process, and 3 to 4A, which is the actual process of the Rankine cycle. And we can calculate the isentropic efficiency of the pump from this equation, which is equal to Ws divided by Wa, and it also equal to H2S minus H1 divided by H2A minus H1. H2S is the enthalpy at the isentropic, and H2A is the enthalpy at the for the actual process. We also can calculate the isentropic efficiency of the turbine, which is from this equation. It is equal to Wa divided by Ws, and it also equal to H3 minus H4A divided by H3 minus H4S. And from this equation, these two equations, we can calculate the new thermal efficiency of the system from this equation, which is it is equal to work net divided by Q in, and it is also equal to 1 minus Q out divided by Q in. Actual vapor power cycle. So this is the simplified diagram of the actual vapor power cycle. As you can see, from steam is generated from the boiler, and it goes into the turbine, and during it movement in the piping, we have a heat loss in the piping, and the remaining heat from the heat loss goes into the turbine, and in the turbine also we have a heat loss there, and the remaining of it will generate heat to produce useful work into the generator, and the output of it goes into the condenser, where the heat is released to the surrounding and goes back into the pump and into the steam generator or the boiler. So as you can see in this actual vapor cycle, we have heat loss in the piping and also heat loss to the surrounding by the turbine. This is the end of part 3 for chapter 4. Thank you, and hopefully you enjoy my video.